Hey guys, you're back with Mr. C, and this is lesson DLM 040, and we're going to be reviewing all of the shapes of quadrilaterals today. So we have now a square, and you can see that the square will always have 90-degree angles. Doesn't matter what you do with it, it'll always be 90 degrees, and then the sides will always be the same exact measurement. The sides always stay the same. So whatever I do, the sides always change the same, and the angles always stay at 90. So that's what a square is. Doesn't matter how big or small it is, the sides are always exactly the same, and the angles are always 90. That's what a square is. Now for a rectangle, for rectangles, the angles will still stay 90, but the sides will change. So if I have the units of 280 here, these will be the same, and the other sides will be the same. So opposite sides are the same measurement, but the angles are always 90. Okay, so there you go. So the opposite sides on a rectangle are always the same, but then the angles are always at 90. That's what a rectangle is. So let's talk about a parallelogram now. For parallelogram, what you're going to have is two pairs of parallel sides, and opposite sides will be equal. So let's take a look at that. You can see as I move this around, let's say this number and this number here, take a look at those two. They'll always be the same number. Whenever I stop, it's the same number. The same thing here, 183, 183. Now, I move it, and they always stay the same. So they're going to always be opposite sides will be the same measurement, and then opposite angles. Take a look at the angles this time. Let's go ahead and get rid of the sides. Take a look at angles now. Angles now will always stay the same. They'll be opposite, but the same. So 132, 148. I change things around, and now they are different numbers, but they are opposite, the same. That's what a parallelogram is. Get rid of the side there, and you can see that the angles may change now, but the opposite sides will be the same measurement. So 116, 135, 135, and I can make this back into a rectangle. Angles there. Yeah. So even though this would be called a rectangle, it's still a parallelogram because opposite sides are equal. Opposite sides are equal, and then these angles are all 90 degrees. When I move it, now it's a parallelogram. Okay, so that's what a parallelogram is. Well, we talked about parallelogram, square, and rectangle. Talk about a rhombus now. And a rhombus is a parallelogram with 4 equal sides. So watch when I move this now. I'm going to take all the things off. When I move it now, all 4 sides will always stay the same length. All 4 sides. Let me go ahead and put the side measurement on. You'll see that it always stays the same length. If I grab anything at all, they're always going to stay 150. And so that's what a rhombus is. The angles may change, but the measurements of the actual sides will always stay the same. They will not change. No matter how skinny it is, they're still 150. Okay? So that's what a rhombus is. And again, if I go to the angles, you can see I can go back to a square. A square is also a rhombus. When the angles are exactly 90, and the sides are all the same, now it becomes a square. So a rhombus can sometimes be a square. Measurements always stay the same. Okay. So do you think then a rhombus could ever be a rectangle? Yes or no? Think about it. Could a rhombus ever be a rectangle? So the answer is no, because, sorry, the answer is no. A rectangle could never be a rhombus, because remember, a rhombus has all four sides the same length, and a rectangle has opposite sides only the same length. So let's move on to a trapezoid. And the trapezoid has one side that has parallel lines. Let's go ahead and, so these two sides here are parallel to each other. And the other two sides are not parallel. So this one here, this line here is parallel to this one. And then this one here is not parallel. But you can see this one has 90-degree angles here. And sometimes it will have 90-degree angles and sometimes it won't. But you can see that this AB line is always parallel to line DC. Let's go ahead and move things around now. And things remain parallel. So line AB is always parallel to line D and C. See that? Whatever I do, they're still parallel. And they may be funky shapes, but these lines here, this line here and this line here are always parallel. So we move this one around. You see AB and DC still remain parallel to each other. That's what makes this a trapezoid. Okay. So most trapezoids you think of normally are going to be, let me get rid of the angles. They look like this. That's what most people think of a trapezoid. Or they look like something like that. It's trapezoid. Trapezoid looks like that a lot of the times. But if you have a funky looking thing like this, could still be a trapezoid, because even though you think, whoa, it looks just like a quadrilateral. Well, these two sides here are parallel. This one here, AB is still parallel to CD. So there's still a trapezoid. Always with a trapezoid, there's going to be two opposite lines that are parallel. That's the key to a trapezoid. Okay, so the last one's a kite. And kites and trapezoid looks very similar. However, there's a different rule for kites. I want you to pay attention. For kites, they have something that's called adjacent angles. So an adjacent angle is an angle that has a side touching. So C, B, A are adjacent. Okay, this line here and this line here touch at line B here. So these angles here would be adjacent. This C, B, and AB are adjacent. It means they touch here. So the other adjacent angle would be angle CDA. And CDA is adjacent because CD is adjacent to AD. And they touch here at this point. So what I want you to notice here for a kite, the difference between a kite and a trapezoid is adjacent angles, this angle here, and this angle here will always be the same angle. So watch, when I do this, this is still a kite, and even this is a kite, and even this is a kite, and that's a kite. So adjacent angles have the same measurement. See that? 178, 47, 47. That's different from a trapezoid. So if I move this out here, now I have, let's say, 200. This angle, this side and this side will always be the same exact, and this adjacent angle will have the same exact number. So 96 and 96 there, 200 and 200 there. Okay, so whatever I do for a kite, the reason why a kite is different than a trapezoid is adjacent angles here are the same. So I may have something that is a rhombus. Let me try to make this into a rhombus now. So 108, 73, 73, and make this 71. Okay, so now this is now a rhombus, but it's also a kite. Remember, a rhombus has parallel. It's a parallelogram with 4 equal sides. So all sides are now equal. So this now is a kite and a parallelogram, and also a rhombus, because a rhombus has 4 equal sides. So things can be more than one thing at one time. This one is all 3 things. Well, it's actually all 4 things. It's a quadrilateral because it has 4 sides. It's a parallelogram, it's a rhombus, and a kite. As I move things around, it changes things. Put the sides back on. Now it's a kite. It's a kite now because the adjacent angles here are the same length, and this adjacent angle here is the same. So opposite adjacent angles on a kite are the same lengths on the sides there. That's what a kite is. So let's go ahead and review here real quick. A square has angles that are always 90, and big or small doesn't matter. These sides always stay the same, exactly the same numbers, and the angles are always 90. Rectangle. For rectangle, the angles are always 90, but the opposite sides were always the same length. Opposite sides always the same. That's what a rectangle is. And let's do a parallelogram now. Parallelograms have opposite sides the same and opposite angles the same. Opposite sides the same, parallelogram, just like a rectangle, but now the opposite angles are always the same. And sometimes you may end up with something like this, where they're exactly 90. That's also a rectangle, and that's also a parallelogram. Same rules, okay? So they are opposite sides there, just like a rectangle. And the angles are different, but the opposite corners are the same exact number. That's a parallelogram. But once they go to all 90, like that, that becomes a rectangle. Okay? All right, so moving on. And a rhombus is a parallelogram with 4 equal sides. The sides will always stay the same for a rhombus. Always, always, always. Always, always, always. Let's go ahead and try to make this a different shape. It's a different size here. Let's see what I get. Go to rhombus. Yeah, I'd always make it a 150. So if I move things around, the angles can change, but the sides will always stay exactly the same. That's what a rhombus is. A rhombus has the sides that are exactly the same length. That's what a rhombus is. Alright, so it's a rhombus. The sides stay the same, but the angles may change. That's what a rhombus is. Then a trapezoid. Trapezoid has always one side, even though they look really funky. Opposite sides will always be parallel to each other. So long as opposite sides are parallel. This one here and this one here, they may all have different lengths, but there's always one set of parallel lines. Look for one set of parallel lines, and that's going to be a trapezoid. Okay, so always there's going to be one set of parallel lines somewhere, and that'll be a trapezoid. These are all trapezoids, but they have one set of parallel lines. Okay, and the last one's a kite, and kites have adjacent angles that have the same measurement. So here 137, 137, this angle here, okay, do we have an adjacent angle CBA? The sides are 171 and 171. So adjacent opposite angles on a kite will always be the same. That's why kites look a lot like trapezoids, but they're different. And that's why this is a kite. Let's do a regular kite shape here. Get this up here, make a regular kite shape. The most think of that's a kite. Okay, so I'm going to go ahead and make a regular kite shape, like a kite in the sky. So that's a regular kite shape, you may see. But also, that's a kite, that's a kite, that's a kite, that's a kite, that's a kite. These are all kites. Okay, so don't just think of like a kite like this. Kites can be really weirdly shaped. Even a rhombus can be a kite. So those are all kites, those are all kites, those are all kites, those are all kites. Because on a kite, adjacent angles have the same measurement on each side, and then opposite side, same thing. That's what a kite is. Okay, so please keep on messing around with quadrilaterals on the interactive sites. And thank you for learning with Mr. C.